All right, in this video we will be looking at some exceptions. There's always an exception to every rule, remember? Exceptions to the octet rule. And just as a refresher, the octet rule just says that every atom, except for hydrogen, of course, wants to have 8 electrons when we draw the Lewis structure. So the first exception are what we call electron deficient. Whoa, having trouble spelling. Deficient. There we go. Elements. Okay, still having trouble spelling. Electron deficient elements. And there's two that I want to, well, 3 elements that we'll talk about here. Boron, beryllium, boron, and aluminum. Okay. They don't always have to have a full octet. We're not going to really worry about why that is, but I'll just give you some examples. If we look at BF3, if we add up all of the electrons there, we have 3 electrons for boron, plus 3 times 7 electrons for fluorine, and we get 24 electrons. And we know fluorine is never in the middle. So when we do our Lewis structure, we have B, F, 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 and that leaves us enough electrons to put around the fluorines in pairs. And that's, there's 8 electrons there, 8 electrons there, 8 electrons there. That is 24 electrons. All the fluorines have a full octet, but the boron does not have a full octet. So you might be tempted to do this, to draw the structure this way with that double bond. Okay. Now we never ever see a double bond to fluorine, and this is not the structure for BF3. So I'm just going to go ahead and cross that out. I do not want you guys to do that. I'm showing you because it is a very, very common mistake I see, and I don't want you to make that mistake. This is the correct structure for BF3. And there is experimental evidence for why that is. If we have a BF3 molecule, oops, wrong pen. If we have a BF3 molecule with its 3 fluorines, because it's what we call an electron deficient element or a molecule, it can react with something like NH3 that has a lone pair of electrons. If you do the Lewis structure for NH3, you'll find that there's a lone pair there. Well, now if we form a bond between these two, if those electrons go to boron and form a bond, what we see, if they form that bond, we know that boron was what we call electron deficient, and that is in fact what we see in a lab. If we combine these two, BF3 and NH3, they do form this larger molecule. And that is the evidence that we don't have that double bond in the boron BF3. It's just a single bond, and boron is electron deficient. Okay. Now, for just one other example for electron deficient is BeH2. This is a highly, highly complicated Lewis structure. 2 electrons for boron, 2 hydrogens, 1 electron each, gives us 4 electrons. And let's see if we can do this Lewis structure. Boy, it's tough. B, E, H, and H. There we go. That's it. Okay. Beryllium, again, electron deficient. It does not always have a full octet. And I think that's where we'll leave that, and we'll do expanded octets in the next video.